Similar figures. So we've got polygons. A polygon, a figure with 3 or more sides or 3 or more angles. For example, triangles, parallelograms, trapezoids, and all other polygons. Similar figures are two polygons which have the same shape but not the same size. One shape is essentially a smaller or larger version of the other, kind of like dilations, where one is bigger or smaller than the other. The symbol for similar, it looks like a sideways S, so that's your similar notation. Or we have this symbol right here, which is the symbol for congruent. And remember, congruent means they are equal. Some attributes. When two polygons are similar, the lengths of corresponding sides are proportional, and the measures of corresponding angles are congruent. They're equal to each other. So let's see. On this side right here, it just shows you examples of what similar figures would look like. Bigger, smaller than each other. Continuing here, we can see the color coding. Corresponding sides, if two figures are similar, then the ratios of the lengths of any pair of corresponding sides are equivalent. So you can see over here, AB, which is here the red, goes with DE, or BC, the blue one, goes with EF, the other blue one. So those match up. That's what corresponding is, when they're in the same position of each figure. And on the next slide, it's just some more examples of putting your corresponding ratios together. Next slide is referring to the angles. You can see here the angle markings. So when they're marked the same, those are corresponding, and when they're the same also, they are congruent. So angle B corresponds with angle E, and they are the same angle measure. Angle A corresponds with angle D, and they are the same angle measure also. And same thing with angle C and angle F. When we go to the next slide, we can see how to find the missing side length of similar figures. So one way you can do that is going between the figures. You see my arrows, it goes from one figure to the other figure, one figure to the other figure, but I was consistent and went from the small picture, small red side, to the big red side, the small green side, to the big green side. And that's what it's labeled over here. So I set up the proportion, 3 over x, so you can see here, 3 red, x red, over 4 and 6. So 4 over here green, 6 over here green. Solve your proportion, cross multiply. 3 times 6 gives you 18. Then divide by the 4 and you get 4.5. So the missing side length, x, is 4.5. Another way you can find that missing side length is within the figure. So here I went from the red side of the small figure to the green side of the small figure, and the red side of the big figure to the green side of the big figure. Okay, again, here's just the labeling of the side names. So 3 over 4, x over 6. You have to be consistent. Notice red over green, red over green. Solve your proportion just like before, and you're still going to get the same side measurement of 4.5. So whichever you prefer, that's up to you. Now when we look at the next slide, what happens when the figures aren't drawn in the same aspect? So sometimes you'll have the pictures, they won't be in the same position. They might be rotated, they might be reflected. So over here, you'll want to redraw your figures so they're in the same position. So you can see right over here, the two trapezoids are redrawn because these ones were twisted around. So they're in the same position, so you can match up your corresponding sides. Now on those two trapezoid, if I had measurements and I had to find the missing side, the x over here, I can set up a proportion because the corresponding sides are proportional. This example shows it set up between the figures, so I went from the black side of the big figure to the black side of the small figure, the red side of the big figure to the red side of the small figure. So I've got 8 over x, 5 over 3, solve your proportion, cross multiply, 8 times 3, 24, divided by 5, you get 4.8. Or just like before, same figures, but this time I'm going to go within the figures. So I went from the black side of the big figure to the red side of the big figure, the black side of the small to the red side of the small. 8 over 5, x over 3, cross multiply, 8 times 3. Notice we did 8 times 3 on the other one too, and divided by 5, we still got 4.8. So since the sides of similar figures are proportional, you will set up a proportion to find your missing side length. Make sure you're consistent when you're setting up your proportion. So we just saw figures where they were rotated and not in the same position, so we redrew them. But now when I go to the next figure, we have one figure inside of the other figure. So of course, we're going to have to redraw it so they are separate, because these ones get a little tricky. You can see I redrew them. I have them in the same position, put my information on each of them. Now I'm going to go ahead and find the missing measurement. Okay, so on this one, again, just like before, I did this one between the figures. So the big red over the small red, the big black over the small black, x over 11.25, 8 over 6, solve that proportion, cross multiply, 11.25 times 8, then divide by 6, and you get 15 for the missing side length. So continuing on, same figures, but now within. Big red over big black, small red over small black, set up the proportion, solve the proportion, and still you get 15 for your missing side length. Okay? Now there are some videos here at the end for extra examples, but what you need to remember for similar figures, when they are inside of each other, you need to draw them separate and then set up your proportion to find the missing side length. When they are rotated, you want to redraw the figures so they're in the same position. Set up your proportion, making sure you're consistent whether you do it between the figures or within the figures. And, well, if they're in the same position, that's easy. Just make sure you are consistent when you're setting up your proportion to find the missing side length. Good luck with the assignment.